Okay, in this video we're just going to practice a little bit more graphing rational functions. Now notice again, like on number one, if it's a reciprocal function, you can very quickly and easily identify all transformations, or in this case, this is going to be your domain restrictions. X can never equal -5, which when you're dealing with these functions, that's going to be your vertical asymptote. Your range values, this is going to be your horizontal asymptote, which is going to be at y equals a -2. And that will be your range restriction. Y will not be able to equal -2. And again, because it's a reciprocal functions, you can graph those asymptote lines. And from there, just again, simply plug in some x values, find some y values, plot the points, and here's what your graph looks like. Okay, again, those can be graphed also with identifying the points on your parent function and applying these two very simple transformations, which would have moved your graph left 5 and down 2. The next problem, same thing. First step, let's identify any domain restrictions, and that's going to be x cannot be 0. And that is going to be your vertical asymptote is the reason it's a restriction. Your range restrictions here, since it is a reciprocal function, is going to be y cannot be 6, and that will be a horizontal asymptote at y equals 6. Let's go ahead and plot those. And next up, I'm just going to simply, again, plug in some x values, do me a t-table, plot my points, and here's what it's going to look like. And again, we could have also used our transformations to find those points. Number 3. Here we have a rational function. This is not a plain simple reciprocal function. So first off, again, I like to identify all domain restrictions. X will not equal 2 here. Since x minus 2 is not a factor of a top, then that's going to be a vertical asymptote at that 2. And you will not have a hole in your graph here. So x equals 2 is your vertical asymptote. Find the horizontal. You look at your leading coefficients because top and bottom are x to the first. So your horizontal asymptote is going to be y equals 1 over 1. And there is your two asymptote lines. Next up, let's find our x-intercept. We find the x-intercept by setting the top equal to 0. So you get -7, 0. Something, again, we don't talk enough of is you can also find the y-intercept very easily. The way you find a y-intercept is plugging in 0 for x. So a y-intercept for this graph, when you were to plug in 0 for x, it gives you 7 over -2, which would be -7/2 or -3.5. Let's plot those. Next up, again, I'm just going to simply find me some more x values. I'm going to plug those in to give me some more dots on my graph. And there you see a picture of your graph. Your only range restriction because of your horizontal asymptote is going to be at the value of 1. Everything else is going to be legal. Number 4. Again, step number 1, we always factor out the 2 on top. You're left with an x plus 1. On bottom, you have difference of squares, which factors into conjugates, plus and minus, x times itself and 1 times itself. So therefore, your two domain restrictions are going to be located at x can't be -1 and x can't be +1. Since you have the removable discontinuity at -1, it will be a hole. In order to find the y value of the whole, clean it up, you have 2 over x minus 1. We can now plug that -1 in. That'll be 2 over -2, which is -1. So you have a hole located at -1, -1. Your other domain restriction will result in a vertical asymptote, so that's going to be at x equals 1. Your horizontal asymptote, since the top power is greatest one is a 1, bottom power is greatest is a 2, so therefore you'll have a horizontal asymptote located at y equals 0 per the rules. And there are the two asymptote lines. X-intercepts, you can set the top equal to 0 to find the x-intercept, and since 2 can never equal 0, there will not be an x-intercept, and the reason for that is because the horizontal asymptote is on the x-intercept. Again, you can find a y-intercept by plugging in 0 for all the x's, so this goes away, and that gives you -2 if you'd like to go ahead and plot it as a y-intercept. Plug in some points or plug in some x values to find more points on your graph, and here's what it'll look like. So that now that we have our graph, we can now look at our range restrictions. Your y restrictions, there's only 2 of them. And that's because of the horizontal asymptote is going to create one of them, so y will never be 0. And your other one, y will never equal this because of the hole being in your graph at negative 1. So y is never equal to negative 1. Okay, number 5, first step, again, we're going to factor two sets of parentheses. That'll be an x times x, adds, multiplies as a positive 2 and a negative 1. On bottom, we're going to factor out a 3. We're left with an x plus 2. So therefore, our only domain restriction is going to be that x cannot equal negative 2. It is a removable discontinuity, however, so therefore that is going to create a hole at negative 2, and there's not going to be, because of that, there will be no vertical asymptotes. We're going to clean it up. We have x minus 1 over 3. So therefore, our horizontal asymptote, since the top degree is bigger than the bottom, because the bottom there are no x's, so the degree is 0, there's not going to be any horizontal. I didn't find the y value of the whole. To find the y value of the whole, you're simply going to now plug that negative 2 in. That gives you negative 3 over 3, which is a negative 1. So your whole is located at negative 2, negative 1. The x-intercept, you can set the top equal to 0. That gives you a 1, 0. So your x-intercept is located right here. So you can plug in some values from here on out, or here's the other method. Notice that this is actually, when you split it, it's a line. That's in y equals mx plus b form. Y equals 1/3 x minus 1/3. That's a line that has a slope of 1/3. So you can actually take this point that's on your graph, or this hole, and you can just do the rise 1, run 3 over and over and over to get more points that are going to be on the lines, or go down 1 and left, 1, 2, 3. And there is going to be what your graph looks like. Now, unlike a line, though, the range values, there is going to be this excluded value because it's a line with a hole in it. So y will never equal negative 1 because of the hole at negative 2, negative 1. Next up, let's again factor. Factor the top two sets of parentheses. X and x, adds and multiplies will be a negative 2 and a negative 4. On bottom, x and x, adds, multiplies is a negative 9 and a negative 4 as well. So your two domain restrictions are going to be x will never be 4 or 9. You do have a removable discontinuity at x equals 4, so there's a hole at 4, and there is a vertical asymptote at the 9. Let's go ahead and clean that up. You now have x minus 2 over x minus 9, which we can use that to graph. To find out where a hole is located, now we can plug 4 into our cleaned up graph, or cleaned up equation. That'll be 4 minus 2 is 2 over negative 5. 2 over negative 5, that's going to be negative 2/5 is where your hole is located. So 1, 2, 3, 4, negative 2/5, somewhere right in there. The horizontal asymptote, we can use our cleaned up graph or the original. Look at the powers on top and bottom. Since they're the same, then we're going to look at the coefficients out front. That's going to be y equals 1 over 1. Here's our two asymptote lines. Next up, to find our x-intercept, we can simply set the top equal to 0, and that's going to be located at 2, 0 then. So there's your x-intercept. Plugging in more points to find, plugging in more x values to find points on your graph. Here's what those other points in the graph would look like. And that nearly cut the rest of the graph off because it would come down to this asymptote line and do that as well. Your range values, there are two restrictions because of the horizontal asymptote at 1. Y will not be 1, and because of the hole, which is located at y equals negative 2/5, there will not be a value there for y as well. Next up, again, let's factor first. Now on the bottom, we will have to use slip and slide, but I'm going to go ahead and factor it. And there's your factored form. Again, I just factored an x out on top, use slip and slide on bottom. My domain restrictions, x cannot be 3/2 when you set 2x minus 3 equal to 0, or negative 5. Since x plus 5 is a factor on top and bottom, then that means that there will be a hole located at negative 5, and there will be a vertical asymptote located at 3/2. Clean it up, that gives you an x over 2x minus 3. That allows us to plug our negative 5 in to find out where the hole is located. When I do that, I get a negative 5 over a negative 13. which is a positive 5/13. So let's go ahead and plot that. Negative 1, 2, 3, 4, 5, and then 5/13 is nearly a half, somewhere right in there. Our horizontal asymptote, since the degree on the top and bottom are both 1, we'll look at those leading coefficients. So we'll have a horizontal asymptote at 1/2, and here those are. And you can see that horizontal asymptote nearly was right on top of the hole as well, but there's a little bit of space in between them. Next up, we are going to find an x-intercept. Find an x-intercept, we can set the top equal to 0, and you're going to get 0. There you go. Now to finish up our graph, we're going to go ahead and plug some x values in to find some points that are going to be on the graph, and here's what that's going to look like. Okay, there is your graph. I forgot to write our x-intercept down. Our domain restrictions, we have our range restrictions. We will have 2 different range restrictions. One of them because of the horizontal asymptote at 1/2. The other one because of the y value of the hole, which was 5/13. So there's your 2 range restrictions. Next up says write a reciprocal function. And reminder that a reciprocal function, the parent is f of x equals 1/x. That has asymptote lines at x equals 4. So let's start with that one. If it has an asymptote line at x equals 4, that means the bottom is going to be an x minus 4. It has a horizontal asymptote at -9. Well, right here is where the horizontal asymptotes are located. So there it would be that function. And number 9 says write a rational function with an x-intercept at 1, 0. Reminder, to find the x-intercept, we set the top of our function equal to 0. So therefore, let's start there. So therefore, on top, we would have to have an x minus 1 to have an x-intercept of 1. We have a vertical asymptote at x equals -3. So we set the bottom equal to 0 to find a vertical asymptote. And another one at x equals -5. So there must be an x plus 5 on bottom as well. What would be the horizontal asymptote? This would be the function, and you could actually multiply it out if you'd like. When you FOIL the bottom, you would get x squared plus 8x plus 15. Now, what would be the horizontal asymptote? Well, that's when you would look at the degrees. The degree of the top is 1, the degree of the bottom is 2. So therefore, the horizontal asymptote, we'll just call it HA, would be at y equals 0 is the rule.